All right, so
I can look at angle at,
wait, no more killing of animals in the classroom, unless they're large.
Okay, let's not take that out of context on video.
No, that's why I said it, to get it out of context on the video. So let's do number 24 and 8.1.
It was a spider.
So we want to use the, what? What did they ask? They tell us tangent of theta is sine of theta over cosine theta. And they want us to kind of, what? Figure this out using the ratios of sides. Is that maybe the problem what they were asking for? Okay. So what they say is, using the definition of trig functions in terms of the lengths of the sides of a right triangle, explain why tangent of theta is sine of theta over cosine of theta, right? What they really mean by that is, think about SOHCAHTOA and show us that this is true. You guys all see that? Okay. So I'm going to think about SOHCAHTOA. So specifically for tangent, I'm going to think about
Opposite over adjacent.
opposite over adjacent, right? The TOA part. Over here, for sine, I'm going to think about
Opposite over adjacent.
opposite over hypotenuse, right? The so part. And then cosine is the adjacent over the hypotenuse. Okay, so I see an opposite and adjacent, right? You guys see that? So I'm going to kind of say something like this. I'm going to say tangent of theta is the opposite over the adjacent. And maybe I should have like a picture in the back of my mind so I can say equals instead of think, right? So the picture I'm thinking of is this one, right, where I've got a right triangle, I've got an angle theta, and I've got three sides. I'm calling them adjacent with various spellings, right?
You could also just use the sine, cosine, tangent, because you're putting them equal to each other. Right? Oh, when you're
You're
looking
trying to prove that
Yeah, I'm trying to show that this is true.
you can't use what you're trying to
Oh,
prove.
that's true. Yeah.
You guys see that? So this equal sign is kind of forbidden from me because that's what I'm trying to demonstrate.
Right. Yeah.
So I'm going to start with tangent, right? And I'm going to say, okay, tangent is the opposite over the adjacent, right? And then what do I need to see the sine and cosine in there? It looks like I need,
Opposite over hypotenuse.
yeah, I need hypoteni in there, right? So I'm going to multiply top and bottom of this by,
Wouldn't it be easier to kind of realize that you're dividing by two fractions, sine and cosine, and then multiplying the reciprocal?
sure, you could do this starting from the other side. That would be totally fine.
Okay.
I'm going to do it this way because I want to say the word hypoteni.
Okay.
So I'm going to multiply by 1 over the hypotenuse and 1 over the hypotenuse, right? To introduce the hypoteni. You guys all see that? So this is going to get me the opposite over the, oh Lord, this capitalization business is all messed up. Assume the capitalization doesn't matter for this problem. So I got now opposite over the hypotenuse over the adjacent over the hypotenuse. And that, of course, is, yeah, on the one hand, that's tangent, right? Because all I did was multiply by 1. But on the other hand, that's sine of theta over cosine of theta. And because this is all equality, right? It doesn't matter which way you go. You guys see that? And so because I wanted to say hypoteni, I was going that way. If you wanted to say onesie some hypoteni, you could go that way. You guys cool with that? Questions there? Okay, cool.
Yeah, that seems like a question we could easily think.
Yeah, this is one that you could hugely overthink. Because what they're asking seems kind of complicated, right? But really it's just, yeah, SOHCAHTOA, plug it in, play with fractions for a second. On this?
So 1 over the hypotenuse, that is a fun one.
Yeah, this whole thing
Is
here?
that implying that the opposite and the adjacent are also 1?
No, this object here is 1 though, right? So really maybe if I was doing this most honestly, I would have had tangent of theta is opposite over adjacent is opposite over adjacent times 1 is that way. Does that make sense? Like really, I'm just multiplying by 1, which I'm allowed to do. As long as the hypotenuse isn't 0, this is definitely 1. If the hypotenuse is 0, this is a weird-ass triangle. Guys see that? Cool? Questions, thing?
Yeah. No, right? Because then the other, one of the other sides would have to be 0 as well, and you just have a line.
Don't think too hard about degenerate triangles. It'll hurt your brain. You guys okay with that?
One side good on the top.
If you want to think about that one, if the hypotenuse is 0, both the other sides are 0. And it makes tangent weird.
Okay.
Because there's no angles in that triangle. But they still have to, yeah. Don't think too hard about it.